Okay, day 2 of trigonometry. So today the focus is going to be writing on taking the ratios and now actually applying them to solving for missing sides or angles. All right, and it's a very systematic approach to this, and if you understand the system, it's not hard at all. And if you don't understand the system, it is hard. So let's give some attention to the system, obviously. So, to solve for a missing side or angle of a right triangle, here's what I want you to do. The first thing, all right, after you make sure you're dealing with a right triangle and you realize it's a trig problem, you're going to identify which sides are involved, all right, meaning opposite, adjacent, hypotenuse. It's going to be two of them most likely, all right, and you're going to be basing that off of whatever acute angle you're dealing with. All right, so you're going to have one of the acute angles are going to be involved, and you're going to have probably either opposite and adjacent, or opposite and hypotenuse, or adjacent and hypotenuse. Now, based on which two are involved, you're going to choose the appropriate trig ratio. All right, so what am I talking about? So you have SO, CA, TOA that we learned yesterday. All right, so follow this. If I had the opposite side and the hypotenuse, well, then I know it's a sine problem. If I had adjacent and hypotenuse in that picture, I know it's a cosine problem. If I had opposite and adjacent, I know it's tangent. So based on whichever two sides you have involved, that's the trig ratio, sine, cosine, or tangent that you choose. Then you'll write an equation. Super easy. All right? You're going to use your calculator, and we're going to talk about making sure it's in the proper mode and all that. And then you're going to solve and finish, which is middle school level. All right? So, first the calculator. Now, in the day 17 or whatever it is to do, there's a calculator link or a search word, I should say, that you can search on in your app store of your phone. It's Calculate 84, one word. And there's a great graphing calculator that really emulates the TI-84 Plus that I'd strongly recommend you download. Um, it's fantastic. It's better than this calculator and set up the same way. So anyhow, when you turn your calculator on, it's important to always hit the mode key. You see the mode key under my finger here? Check the mode key, and you should be on the third row. You have radians and degrees. It's important that you're in degrees. All right, so if you're not, like if you were in radians and your calculator looked like that, you would go up, hover over degrees, hit enter. All right, we'll quit out of that. And then the easiest way to check it is just to always remember what the sine, here's your sine button, sine, cosine, tangent on the bottom here. Well, middle of your calculator, bottom of the screen right now. Sine, cosine, tangent. Sine of 30 degrees should always equal 0.5, and it does. If you're in the wrong mode, you're going to get some ugly decimal, which if memory serves me right is like, I don't know, negative 0.988 or something. There you go, negative 0.988. All right, so that's the wrong mode. Every answer you get will be wrong, even though your work would be right. So we're going to leave it in degrees, make sure we're there, quit back out of that, double check, sine 30.5. Great, I know I'm in the right mode. Okay, so let's look at our first problem. For each of the following, use the trigonometric ratios to solve for the missing side x. Okay, so I look at this. I have a right angle symbol, great, it's a right triangle, fantastic. I have this 40-degree angle right here. That's my acute angle that I'm going to reference everything from. So, relative to this 40-degree angle, I'm going to decide what sides these are. Now, you should remember, hypotenuse is the hypotenuse is the hypotenuse. So you should ask yourself right away, is the hypotenuse involved? Is 9 or x the hypotenuse? Is it the largest side across from the right angle? Here's the right angle. Across, it is. So this has your hypotenuse involved. Okay, so again, based off this acute angle, I have these two legs of the right triangle. X is one of the legs. It's clearly involved because it's what I'm solving for. So relative to this 40, is this adjacent or opposite? Adjacent or opposite? And of course it's adjacent. So this problem, this first problem, involves your adjacent and your hypotenuse. So again, if I think back to so, ka, toa, which one, sine, cosine, or tangent, involves A and H? And you look, A and H makes cosine. So I'm going to write cosine. Now, cosine of what? Always the angle. Always the acute angle you're going to be writing here for this course at least. So cosine of 40. Then an equal sign. Well, what does cosine equal? Cosine equaled adjacent over hypotenuse. Cosine equals adjacent over hypotenuse. So what's the adjacent? X adjacent over the hypotenuse 9. That's the equation. So once you choose sine, cosine, or tangent correctly, right in the equation, it's simple. All you got to do is read it off. All right, now, the next step after you choose the appropriate trig ratio was to write the equation, did that too, and now we'll use our calculator. All right, so I need to know what the cosine of 40 degrees is. So I type, I want to make sure you can see this, cosine 40. You want to close parentheses, go ahead, you don't have to, and I hit enter. Oh, well that's disgusting. That's okay, they're all going to look disgusting for the most part. So I'm going to copy now, oops, that was embarrassing. I'm going to copy this ugly decimal. But my rule of thumb for my students is always give me 4 decimal places. 7660.7660 equals x over 9. Okay, that's fine. I can deal with that. So what do I do now? Well, I think the easiest way to do it is just throw it over 1 and cross multiply. X times 1, of course, is x. I go back to my calculator. I could even use this whole decimal here and just hit times 9. And in these cases, I always have to tell you what I want you to round to. So if our rule of thumb is going to be when I'm looking for a side, let's go to the nearest tenth. So if I'm looking at 6.89, that would round to 6.9. And that's my answer. All right? Let's do the next one. And then I'll stop and we'll go for the second video after. Relative to this is my angle. Again, there's my acute angle. So relative to this angle, what's x? Well, hold on. This is the hypotenuse. The hypotenuse isn't involved at all. All right? Across from, that's opposite. Right next to, that's adjacent. O and A, which one does that come from? Look at it. That's O and H. That's A and H. That's O and A. So this is a tangent problem. Tangent of what? Always the angle. So tangent of 70 equals, tangent equals opposite over adjacent. So what's the opposite side? That's your x. What's your adjacent side? That's a 4. So you wrote the equation, go to the calculator. Tangent button, tangent button, 70, close it or don't, doesn't matter. Enter. Oh, okay, ugly decimal. I got to go 4 decimal places. 2.747, I should really round that, 5 equals x over 4, right? Throw it over 1 and cross multiply. X times 1 is x, and this number times 4. Oh, what am I looking at here? I got to be a little careful. This is 10.989, so I got to round to the nearest tenth. So that 8 makes this 9 a 0, which makes this 1 a 0 a 1. So it's 11, and since I'm rounding to the nearest tenth, I have to have something in the tenths column. And that's that. All right? So I'm going to do 2 more of these in the second video, and then I'm going to show you how to find the missing angle. All right, I hope you followed that.